Calculus and Vectors, grade 12 textbook. The initial question states, Evangelistia Torricelli developed a formula for calculating the barometric pressure for various altitudes. The altimeter of an aircraft uses a similar formula to determine the altitude of the aircraft above sea level. The formula has the form P equals 101.3 e to the negative kh for the atmosphere at standard pressure and temperature, where P is the barometric pressure in kilopascals, h is the altitude in meters, and k is a constant. So for part A, it states if the barometric pressure at an altitude of 1,000 meters is 95.6 kPa, determine the value of K. So from the initial part of the question, we know a couple things. We know P, or pressure, so P is equal to 95.6 kilopascals. We also know that H is equal to 1,000 meters. So now that we have these values, all we have to do is plug it into our equation. So we know our equation is P is equal to 101.3 e to the exponent negative kh. So now that we know this, we can determine the value of k, that's the question asked, by just plugging in the values. So P is 95.6 equals to 101.3 e to the exponent of negative k h, which is 1,000 meters. There, divide both sides by 101.3. So if we divide 95.6 by 101.3, we get 0.9437. 0.9437 on one side, and e to the negative k times 1,000 on the other side. Next, to get rid of the e and to bring down our negative k and 1,000, we put ln on both sides of the equation. So if in this side of the equation we put ln e doesn't matter. We can get it out of there. So ln e equal to 1, it won't be in there. So all we have on this side is negative k, or negative 1,000 k, and the other side will be ln 0.9437. We take the ln of 0.9437 and we get negative 0.0579. And on the other side, we just have negative 1,000 k. Then we divide both sides by 1,000 to get rid of the negative 1,000, to get rid of the negative 1,000 on this side. This side by negative 1,000, and then we get k is equal to 0.000579. And that's our final answer for A. The final answer for A is k is equal to 0.00000579. So now that we figured out part A, we can go on to part B. So part B asks us, show that the value of K from part A correctly predicts a pressure of 90.2 kPa at an altitude of 2,000 meters. So again, first question, first part A. So we already know that from part A, we calculated that K is equal to 0.000579. So that's our value for K. So now essentially all it's asking us is to prove that the equation from part A is equal to, so that means the equation for P has to be equal to 90.2. So essentially all we have to do is make the equation with the K value in it, which would be 101.3 e to the negative 0.000579 times 2,000, so 2,000 meters, this above here. All this has to be equal to 90.2. So essentially left side has to equal to right side. We have to prove that this side is equal to this side. So this is as easy as plugging into your calculator. So the first thing I did, you really want to take it slow as steps. And I multiplied the top two numbers here by each other just to bring down the number size, because that's easier to put into your calculator. So 101.3e to the exponent of, you just multiply those two, you get negative 0.1158 equals 90.2. So now again, it's just as simple as plugging this into your calculator. So plug in 101.3e to the exponent negative 0.1158, and if you plug that all in, you will in fact get 90.2. And so left side indeed equal to right side, so we just answered correctly. In part C, the question states, the vertical speed indicator on an aircraft uses the change in barometric pressure with respect to time to determine the rate of climb of the aircraft. Determine the first derivative of the barometric pressure formula. So this big blurb at the top, not highlighted, is not really important. We just need to focus on the highlighted area to determine the first derivative of the barometric pressure formula. So before we start the question, I just wanted to show you guys a rule. So when we're trying to find the derivative of e to the x, or in this instance I'll use the example 2e to the power of 2x. So to find the first derivative, what we have to do is we have to take the 2 up top here and actually bring it down here. So this turns into 2 times 2e, and then we keep the 2x at the top. 2x. So now that we have this, we multiply everything at the beginning. So 2 times 2 is 4. This equals to 4e to 2x. So that's how we find the first derivative, or 2e to the 2x. So now it says determine the first derivative of the barometric pressure formula. So we know our barometric pressure formula already, which we know is P is equal to 101.3 E, the exponent of negative 0.000579, and the bracket H. So this is our formula. So our first step, like I just showed you over here, is we're actually going to bring down everything here in the bracket. So this big number, so it's going to be 0.0000579 brackets times 101.3e, and then we keep this all up here. So negative 0.0000579 pH. And we multiply these two numbers together, so these two numbers here. Our final answer, E is equal to 0.00587E, negative, right? We're still keeping the top part. 0.0000579 bracket H. And that's our answer to part C, the first derivative of our barometric pressure formula. Now for the last question. To solve question D, which states, determine the rate of change of the pressure with respect to height at an altitude of 1,500 meters. So this is similar to the last question, but since we have to find the derivative for the equation. So we have to find the derivative of the equation of P is equal to, so again, our original equation is 101.3, then E to the H, and then obviously like the negative K. So I kind of just redid the H and the K. So as we can see here, this is how we have to set it up. So we have to find P prime. So to find P prime, kind of like how we did in the last equation, we have to bring down what's in the bracket to the front. So we have to multiply 101.3 times negative K and then we keep it the same. So e to the h negative k again. We plug in our numbers now, so we know 101.3 times negative k, which is negative 0.0000579. Now multiplied by e, and now for h is 1,500 meters. We plug in 1,500 for h. Now negative k again is just 0.0000579. Alright? Plug this whole thing into your calculator right away and you'll get your answer. So p prime is equal to negative 0.0037978. And that is the answer, part B. A career in which one might have to use these equations would be an engineer trying to build a submarine or an aircraft. They have to know the pressure outside as well as inside the cabin, making sure that it's safe for all humans to go in. So using these equations, you can figure out pressure, at what altitude and what height, and make it safe for all humans to be able to go in these submarines or airplanes.